Hello and welcome to Perimeter Area and Volume with me, Bill Haining. Now the aim of today's session is to calculate the area and perimeter of simple shapes, including those that are made up of a combination of rectangles, calculate the volumes of cubes and cuboids. We'll then move up to level 2 and we'll calculate perimeters and areas of 2D shapes, including triangles and circles, and composite shapes, including non-rectangular shapes, and formula given except for triangles and circles. Use formulas to find volume and surface areas of three-dimensional shapes, including cylinders. The formula to be given for 3D shapes other than cylinders. And anything else that comes up. Let's look at the first part of our builder skill, perimeter. We'll start at level 1 and calculate the perimeter of simple shapes, including those that are made up of a combination of rectangles. So what is a perimeter? Well, the perimeter is simply a shape is the distance around the outside of the shape. Now remember that it's the outside, not the inside edges. So let's look at a square. You can see here, okay, that the square, right, means that if it's square, then all sides must be 5. So you just simply add up all the sides and you will see that 5 times 4 is 20. Just remember, it's the distance around the outside of the shape. Let's look at a rectangle. Again, the same. You may be given 2 dimensions. You can see one side is 5 and the other side is 2. Well, if that is 5 along the length there, then this must be 5 as well. And if that's 2, then that must be 2. So therefore, you just put in the missing dimensions and add them all up. And you can see here in this case, the distance around the rectangle is 14 meters. Now let's look at a composite shape. Okay. Now you can see here, they're giving you all the dimensions on the outside of the shape. Now it's quite common in maths for some dimensions to be missing. So for example, if this 4 was missing, for example, how would you know what that is? Well, it's fairly simple. You would take 6 from the opposite side, minus 2, and that leaves 4. But you can see if you add 4 and 2 together, it's the same length as that. Now once you know the outside, all the values of the outside numbers, you just add them together and you can see the distance around there is 24 meters. So that's fairly straightforward. Now it's your chance to try it. Have a go. Stop the video when you get the question. Okay, so a community centre project, films onto a screen. The manager wants to make a wooden border around the screen. She needs to order the wood. There's your screen. Okay, now what length of wood does she need to order? Pause the video, get your answer, and then restart the video. So how did you do? It's fairly simple. 2 plus 1.2 plus 2 plus 1.2 equals 6.4 meters, and that is the distance around the edge of the border. If you got 6.4, well done. Here's another question to test you. Using the measurements given, we can work out the perimeter. All right, often you'll get asked to work out the perimeter of shapes, so you will need to know and use the given measurements to work out the missing measurements. And you can see there, your 2, you get that 2 from taking 6, take away 4, and that gives you 2. And this other missing dimension here, all right, is 4 centimeters, and you get this 4 centimeters by taking 7 and minus 3, which must give you 4. All right, then you just simply add them together. And the perimeter around that composite shape is 26 centimeters. Now let's move up to level 2 and calculate the perimeter of triangles. Okay, let's look at an equilateral triangle. An equilateral triangle just means that all the sides are the same size. So if this is 10 centimeters, that must be 10 centimeters, and this side here must be 10 centimeters. So you just simply, it's 10 times 3. And that tells you the distance around that triangle is 30 centimeters. Now let's look at an isosceles triangle. Okay, you may be presented with something like this, and again, you can see there is a missing dimension here. Okay, well, there's a nice clue there right in the middle of the page. You can see these 2 white lines here. Okay, what that means is if this length is one size, then this side, this length here, the opposite length is the same size. So these just mean they're the same size. Now you may see them as two lines, but normally it's just one line. So that tells you that's 10 plus 15 plus 15, and that gives you a perimeter of 40 centimeters around that triangle. Let's look at the perimeter of a circle. Okay, this is where your formulas start coming into play, and you need to remember what symbols mean. Okay, so first thing you need to remember, the perimeter is your outside edge, and if you remember from your school days, that's the circumference. It's the same thing. So how do we calculate that? Well, we use the formula pi d, or pi multiplied by diameter. So you use BODMAS to solve this kind of problem, okay? And you remember, if you remember your BODMAS, you can see that means pi, which is 3.14, and d is the distance from edge to edge running through the middle, okay? So it's just simply pi times diameter. So in this case, if the diameter is 5, you will have to remember that pi is 3.14, then you simply multiply it by 5, and that tells you the distance around the circle is 15.7. Now, just a note here, for the perimeter of a semicircle, you just simply divide it by 2, and that will give you the distance from there to there. Okay, half the circle. Let's look at the next part of the builder skill, area. Okay, now just remember with perimeter, that's the only one you add. We're now going to move on to area and then on to volume. For these skills, you multiply to find out the area and the volume of a surface or an object. So let's start at 1 and look at area. So what is area? Area is the surface of a flat space or the shape that covers in 2 dimensions. And it's calculated using the formula length times width. So in essence, anything with a straight edge, starting point is length times width. Now you'll see later on when we deal with triangles or we deal with volume, you either deduct from that formula or you add to it. All right, but we'll cover that in a moment or two. So let's look at our square. You can see there the square is 5. Remember the formula is length times width, so it's just simply 5 times 5 is 25. Now don't forget to put your little 2 here, okay, at the end of your final answer. Okay, that tells people you're working in 2 dimensions. You can see the 2 calculations there. Okay, and what that means is, for example, if you were going to lay 1 meter square carpet tiles in that space there, then it's 5 times 5 is 25. So you would need to go out and buy 25 1 meter square carpet tiles to fit that space. Okay, so you're working in 2 dimensions now. The rectangle, you can see there 5 times 2, and again you're working in 2 dimensions. Don't forget your little 2. Now composite shape, let's look at a composite shape. Okay, and you can see there's the dimensions of the composite shape. Now a lot of people look at that and say, oh, I'll never remember the formula and how to calculate that. Well, that's because there is no formula. There's no formula for a composite shape. You have to break it down to the formula you do know. And in this case, you know the formula is length times width. So all we have to do is break this down into 2 rectangles. Okay, and now you've created 2 new shapes. And you can see this one is 2 times 5 and this one is 4 times 2. Okay, so you just fill in the missing gaps, create your little area. Then you work out what these are and then add them together. All right, and just before we do that, just to mention, sometimes when you create these new shapes, there might be a missing dimension. So this may be missing. And just like before, you take the opposite value, 5, minus 3, and what left must be 2. Okay, and that's how you find the missing dimensions. You always go to the opposite side of the shape. So then you just simply, once you work out the area of both shapes, you just add them both together. And 10 plus 8 equals 18 meters squared. Don't forget your little 2. Okay, let's look at a question at level 1. A man wants to buy a bag of gravel to cover his driveway. He decides to work out the area of his driveway. 1 bag of gravel covers 14 meters squared. Now you can see in this shape, okay, you have to work out the area. So it's fairly simple. What is the area of his driveway and how many bags of gravel must he buy? Well, if you think you can solve that, pause the video and have a go and see what sort of answer you come up with. All right, let's see how we do it. You can see there you break it down into the shapes you do know, and you can see now you've got 5 times 3, but you can also see in this case you have a missing dimension because you've created this new shape. Alright, so again 5 minus 3 means that must be 2. Alright, so you put that in there and you can now work out the area of that rectangle. Okay, and then once you've done that, you simply multiply them, add them together, gives you 31 meters squared. So how many bags of gravel do you need? Well, you just simply take that 31 and you divide it by 14 meters. Okay, so 31 divided by 14 is 2.2 bags. Now, this type of question you have to think logically. You cannot buy 0.2 of a bag. So in this case, you would need to buy 3 bags. Okay, because if you only buy 2 bags, you'll be short by 0.2. So 3 bags are needed. And if you got 3 bags in your answer, brilliant, well done. Another question on area. A decorator is painting the room and he has one wall left to paint. They have enough paint to cover 12 meters squared. The dimensions of the wall are shown. Okay. Now they will not paint over the door. Do they have enough paint for the wall? Again, pause the video, have a go and see if you can think you can get the answer. So how did you do? All right, let me show you. Okay, so you can see the simple problem is you take the overall value, which is 4 times 3.25, and you take away the area of the door. Okay, and by doing that, what's left is the area of the green surface, which is the wall. Okay, and you can see it's 11.2 meters squared, and we know that the paint is 12 meters squared, so yes, they do have enough paint. And you can see they're short by 0.8. Now some 0.8 left over. So if you got yes, then well done. Let's look at the areas of a triangle. Right now, all triangles are half a square or half a rectangle. Therefore, the formula is just the same, but divided by 2. So you can see there the formula is not changed. It's length times width, but this time you divide it by 2 because all rectangles are half a square. All triangles are half a square or half a rectangle. So let's look at the equilateral. You can see length times width. Now if you do length times width, it will give you the area of a square. But by dividing it by 2, you will get rid of the excess outside area, okay, and that will give you 50 meters squared. Let's look at an isosceles triangle again. Okay, gives you 10 times 15, exact same again, divide by 2, and that gives you a surface area of 75 centimeters squared. Let's look at a right angle. This is probably the best one to understand why all triangles look like a square, because if you draw the square there, you can see that there's exactly a square, and you can see that line down the middle there between the two squares, well, the middle of the square basically. That's called a line of symmetry, because you can see that this half is a mirror image of this half. Okay, so remember that line of symmetry just cuts a shape in half, okay, and it is a mirror image. All right, and you can just do the same again. 10 times 12 divided by 2 is 60 meters squared. Don't forget your little 2. Let's look at an area of a circle. Now this is where your second formula comes in. Now you remember perimeter, we did pi multiplied by diameter. Now the best way to remember which one to use in this case, if you remember pi times diameter, if you think of the d, pi times the distance around the edge as well. That will help you remember its perimeter. Okay, now area, there you go, there's your circle again. Okay, but this time the formula is pi times radius squared. Now this is where you need to know the characteristics of a circle. So we know that the outside edge is called the circumference or the perimeter. We also know the distance from edge to edge is the diameter. Well, the radius is the point from the center to the edge, and that's exactly half of the diameter. So a radius is half the diameter. Now that's important later on, because sometimes when they're asking you to work out the area of a shape, then they may give you the diameter, so you have to half that and use the radius instead. And vice versa, they may give you the radius when you're asking you to calculate the perimeter of a circle. In that case, you'd need to double the radius to work out the diameter. All right, so you can see here, if the radius was 3, then again, always when you're dealing with anything with a curved edge like this, always start with pi. That's your starting point, because we know we'll quickly get into the habit of knowing that pi is 3.14, because sometimes they won't give you pi in the question. Sometimes they may give you pi, they may give you different numbers for pi. If they give you a different number for pi in a question, use that number, but the default is 3.14. So in this case, it would be 3.14 multiplied by 3 times 3, because remember that this is squared. All right, the second part there, if you remember your Bodmer's rules, okay, you've got pi, nothing in between, multiplied by radius squared, and radius squared just means 3 times 3, which is 9. Okay, so you can see that there, 3.14 times 3 times 3 is 28.26. Again, don't forget your little 2 squared. Now note, for the area of a semicircle, just simply divide by 2. All right, I often get caught out forgetting that you do that for a semicircle. Same formula, but just divide by 2. Let's take a combination of all the things I've learnt so far and work out the area of a composite shape. Again, there is no formula for a composite shape. You must break it down to the formulas you do know, all right, and then add them back together again to calculate the area. All right, so you can see there what we've done. We've broken it down into a triangle, a rectangle, and a semicircle. You've just been taught the formulas for that, so break it down. So you can see there, 4 times 6 divided by 2 gives you the area of the triangle. 5 times 6 gives you the area of the rectangle. And you can see there that 3.14 times 3 times 3, and that there is, you can see there that the diameter is the same down here. So if that's the diameter, half the diameter must be 3, all right, which is the radius. So 3 times 3 gives you the answer to that. Okay, and then because it's a semicircle, you divide by 2. Then you just simply add them all back together again, and that gives you 56.13 centimeters squared. Don't forget your little 2. Now that's as tough as it gets. Okay, so you have to remember these formulas. Remember, the straight edge, it's always starting with length times width. All right, in the case of the triangle, divided by 2. All right, and when it comes to the circles, always start with pi. Then you only have to decide if it's pi times d for the perimeter or pi times radius squared for the area, not forgetting to half it in 2 for a semi. Okay, let's see if you can have a go. Okay, a worker must set a machine to cut the shape from a piece of metal. There's the dimensions. Okay, what is the area of that shape? Pause the video, have a go, and see if you get the correct answer. So how did you do? Well, let's have a look. Break it down into the shapes that you know, the formulas you know, okay? And you can see now you have created 2 shapes. Now you can see also what you've done here. You've created these new shapes and a new dimension. Because if you see the opposite there is 8, minus 2 means that this pattern here must be 4. So that then gives you the dimensions for the triangle, 4, and we can see there the height is 3. Okay, so it's 4 times 3, and because it's a triangle, you divide it by 2. Okay, then the rectangle is simply 8 times 2.5. You do the workings, you add them both together, and you can see the answer is 26 centimeters squared. And if you got that in your answer, well done. Try this one. Tom wants to build a semicircular patio in his garden. Work out the area of the patio. Again, pause the video, have a go, and see what answer you get. So how did you do? It's fairly simple. Okay, remember we're starting with pi, 3.14. Okay, multiplied by radius. It's giving you the radius there is 2, so it's 2 times 2. And because it's a semicircle, you divide by 2. And that will give you an answer of 6.28 meters squared. And if you got that in the answer, you're doing absolutely fantastic. So well done. Let's move on to the next builder skill, and that is volume. Now, when you come across some of the formulas in volume, they're just the exact same as you've done with area. but you're adding that third dimension. So the formula is the same, you're just adding a third dimension, and you'll see what I mean by that. Okay, let's look at volume. Volume is the space that takes up in a cuboid. So the volume of a cube or a cuboid is length times width. All right, you can see it's still the same formula, length times width, but this time you've got the added height to it. So it's length times width times height. Okay, so your starting point is length times width. Now let's look at a cube. Okay, so there's your cuboid or a cube. You can see that all sides then must be 5 centimeters. Okay, because if one side's 5, it's a cube, they're all the same. So the formula is just simply length times width times height. So 5 times 5 times 5 is 125 centimeters cubed. Now you're working with 3 dimensions now. So it's the space that occupies a shape like that. Okay, that's what we're looking to fill. And you can see because you're working in 3 dimensions, you put your little 3 at the end there. Okay, again, same for a cuboid. Okay, length times width times height. All right, you're just extending out that one for area because you're working now in 3 dimensions. So it's 10 times 5 times 5, and you can see that's 250 centimeters cubed. So fairly straightforward with anything with a straight edge. Your starting point is length times width. Right, let's have a go at this and see how you got on. Right, what is the volume of this cube? Stop the video, get your answer and see how you did. So how did you do? Oh, 10 times 10 times 10 is 1,000 centimeters cubed. Don't forget your little 3. Let's have another look at another question. Right, the volume of this cuboid is 24 centimeters cubed. What is the value for the width that's missing? And you can see here that you've got a missing dimension. So how are you going to work that out? Pause the video and then I'll show you. So how did you do? Well, it's fairly simple. You just work in reverse. We know the formula is length times width times height equals volume. You just work backwards. So you can see the volume is 24. So you just divide it by 3 and then divide it by 4. So it gives you 8. So therefore, the answer must be 2 centimeters. Now let's look at the volume of a cylinder. Okay, now you remember the formula for the area of a circle is pi times radius squared. That remains the same. All you're doing in this case for a cylinder, there's your area of the top part, the area of your circle. Now you're adding that third dimension, which is height. Okay, so you multiply it by the height. Okay, so you can see here, pi times radius squared, it's just the same, but you've got the added dimension of height. And that's your Bodmer's formula there. If you understand how Bodmer's works, you can see that's pi multiplied by radius squared multiplied by height. And that's what you're looking to achieve when you're dealing with cylinders. 3.14 times 2 times 2 times 10 is 126.6 centimeters cubed. And that's how you calculate the volume of a cylinder. The formulas I've taught you so far are all the formulas you need to know. But you may be given other shapes and be asked to work out the volume of other shapes. So how do you do that? Well, you'll be given 3D shapes other than cubes or cylinders, like spheres and semispheres, and be asked to calculate these. Okay? Don't panic. They will give you the formula, right? All you need to do is remember which each symbol or letter means, and then follow the Bodmer's rules to calculate. So calculate the following. Right, let's look at a sphere. Okay, and you can see here they're giving you the radius of the sphere. That's all the information you need. They're giving you this formula. And if you know your Bodmer's rules, all that means is 4 divided by 3, because in fractions that's called the dividing line. So 4 divided by 3 multiplied by pi multiplied by radius cubed. All right, and if you lay it out as you're going to type it into your calculator using the information from the question, you can see there that the answer is 113.04 centimeters cubed. All right, now you won't need to remember this formula. All you have to remember is they will give you that and follow the Bodmer's rules. Right, let's look at a square-based pyramid. All right, they're giving you the height and they're giving you the area of the base, which is 3 centimeters. Okay, and they're going to say, there's the formula. Okay, and you can see you don't need to remember that. all you have to remember is a squared. A is 3, so it's 3 times 3 is 9, and it's multiplied by the height, because you always do the top half of a fraction first in BODMAS. So you multiply by the height, which is 5, and then divide by 3. And if you put that into a format you're typing into your calculator, you can see that 3 times 5 divided by 3 is 15 centimeters cubed. All right, so don't worry if you get an odd shape. They will give you the formula for it. Let's look at this question. See if you can answer it. Have a go. What is the volume of this triangular prism? Pause the video. How did you do? Let's have a look. All right. Now you can see that this BHL over 2, if you know your BODMAS rules, you'll know that means base times height times length divided by 2. And there it is as you put it in your calculator. So you just convert these to numbers that you can work with. And you can see it's 16 times 6 times 30 divided by 2 is 1140 centimeters cubed. And as you can see, all the information you need is in that question. As long as you remember the BODMAS rules, you can easily solve this. If you got 1440 centimeters cubed, brilliant, well done. This is a question that comes up in the mock exams, okay? And this is a combination of everything I've just taught you, all right? But most people shy away from this question, and it's really, really important because it is one of the big 6 questions. And this question, believe it or not, is worth 6 points, which if you think about it, is 10% of your overall score just on one question, okay? So let's go through it and break it down. I'll show you how to solve it, giving you the information I've just taught you. Now, a craftsman uses resin to make a paperweight, okay? He makes it from 2 parts, okay? A cylinder and a hemisphere, okay? Right? And he uses the plan seen, all right? How much resin does he need for both parts? Right? You've got all the information in the question you need. Let me show you how to do that. So let's deal with the cylinder first. Now, this is the part that you have to remember, the cylinder. You need to remember the formula. And if you remember rightly, the formula is pi times radius squared times height. Okay? All right, so you can see there, pi times radius squared times height. So you need to remember that. You put it into your calculator once you've converted that formula into numbers, type it in, and you can see the answer is 141.3 centimeters cubed. Now that leaves us with the hemisphere. Okay? So how do we calculate that? Well, we use the information they give us. And if you remember your BODMAS rules, all that means is 2 divided by 3 multiplied by pi multiplied by radius cubed. Okay? And you can see here, once you convert that to numbers you can work with, it's just 2 divided by 3 times 3.14 times 27, and the answer is 56.52. Now if you add them both together, that will give you the total volume for that shape. Okay? And you can see there, adding it together, the answer is 197.82 centimeters cubed. All right, so when you see a question like that, that's as tough as it gets. So remember, the main thing to remember is you have to remember certain formulas, but when it comes to other shapes like hemispheres, spheres, square base pyramids, you will not be asked to remember that. You just need to remember the BODMAS rules. And if you don't know the BODMAS rules, I suggest you look at the BODMAS session. Let's finish this builder skill session by looking at surface area. With surface area, all you're doing is you're taking a 3D shape and converting it to a 2D shape to work out the flat surface of an area. Imagine you want to paint a wall. You don't want to know what's in behind the wall, just what's on the wall. So surface area is simply taking a 3-dimensional shape and calculating the 2-dimensional faces of that shape. So let's have a look. All right, let's, for example, a cube. If you look at that cube, you can see there, once you flatten it out, if you imagine you're working with flat pack furniture and you unpack it, you can see there that on that cube you have 6 sides, all 5 by 5. So to work out the surface area, the areas you want to paint, remember you're not interested in what's inside, you're not interested in the volume, just this surface area here. Then if you imagine that, then all you have to do is the cube has 6 faces. In this case, the face consisting of an area of 5 times 5, therefore the formula is 5 times 5 and that will give you the surface area of one of these cubes. All right, one of these squares, apologies, one of these squares, and you just multiply it by 6, and that tells you that you need 125 centimeters squared. So imagine that was a shed or something like that, you were going to paint that shed. You could go out and confidently buy enough paint to cover that surface area. So let's look at the surface area of a cuboid. Just like the cube, imagine it's in a flat pack situation, and using the given dimensions you can work out that the cuboid has 6 faces, in this case 4 faces of 10 times 5 and 2 faces of 5 times 5 based on the information. So therefore the formula is 10 times 5 times 4, and then you add 5 times 5 times 2, and if you follow the Bodmer's rules you will see there that the surface area of the cuboid in this case is 250 centimeters squared. Let's look at the surface area of a cylinder. Right, you can see there's your cylinder, and if you put that into your flat pack, you can see how it would look if you opened it up and laid it out flat. Now, this is a wee bit more complex than the cubes and the cuboids, but when you understand it, it makes common sense, doesn't it, from the things that I've taught you. So you work out the area of the circle times 2. All right, so to work out the surface area, length, say pi times radius squared, multiplied by 2, and you can see that will give you the surface area of both. Okay, pi r squared times 2. Now you work out the perimeter. Work out the perimeter and then the height. Okay, now we have to figure out what this length is and what the height is. Okay, so the formula for that is pi times diameter times the height. Okay, now we know pi times diameter would give you the perimeter, this here. But if you think about it logically, if you open that up, that would be the same length as that. All right, so by working out the perimeter of the circle, will give you this length. Then all you have to do is multiply it by the height to get that surface area. And then you'd add both together to find the total. So you can see there's your formula for it. Add them both together, and you can see there that the surface area of that cylinder is 150.72 centimeters squared. That is perimeter, area and volume, so I hope that helped. Thank you.